Alrighty, welcome everyone to day 6 of Advent Code. Yesterday was a little rough on part 2, but part 1, not too bad, you know. You win some, you lose some, but anyways, 10 seconds here to the code, to the problem is released. We got our day 6 all set up here. Let's do this. 4, 3, 2, 1. Let's get it. The ferry quickly brings you across Island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here, but you don't see anything besides lots of water in the small island where the ferry is docked. You try to figure out what to do next. You notice a poster on a wall near the ferry dock. Boat races open to the public, grand prizes, all expenses paid trip to Desert Island. Let me see where the sand comes from. Best of all, the boat races are starting in just a few minutes. Manage to sign up as a competitor, and the boat race just in time. The organizer explains that it's not really a tradition race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the furthest. As part of the signing up, you get a sheet of paper plus inputs that list the time allowed for each race and also the best distances ever recorded in that race. To guarantee to win the race, you need to make sure you go further in each race than the current record holder. Fair enough, the organizer brings you over to your area where your boat races are held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows boats to move. Buttons move faster if their button is held longer, but time spent holding the button counts against it. Yep, okay. But released. Example, okay. Aggressive race is the first last 7 milliseconds. The record distance in this is 9 millimeters. The second race is 50 milliseconds. Okay. Toy boat has starting speed is 0 millimeters per second. For each whole millisecond you spend at the beginning of the race holding down the button, the boat's speed increases by 1 millimeter per second. Okay. Optimization problem. Since the current record of this race is 9 millimeters, there are actually 4 different ways you could win. 2, 3, 4, 5. In the second race, you could, to see how much margin area you have, determine the number of ways you can beat the record in each race. For example, if you multiply these values together. Wow, this is a very simple input. Okay. So it's a pretty simple optimization problem, I'm pretty sure. Okay, so let's just do, what's it gonna be? Times equals input, actually I'm gonna call it, put this lines, input, split on new lines. And then times is going to equal to inputs 0 substring 1 2 3 4 5 trim, and I'm gonna do a quick replace all of the double space to single space just to make life a little bit easier. And then we're gonna split on spaces to get our times. Do the same exact thing for the second line. This is gonna be the distances. But it's gonna be 1 2 3 4 5 6 7 8 9. Okay, so I also forgot to change this real quick. I'm gonna do this while I'm thinking about this. So it's me optimization. We need to figure out, given it's 38 seconds, the record is that. I think we can just brute force this. I'm gonna call this const times. No, this is going to be options is going to equal to times map. So you get the index. So given this time, we need to do, we need to build up an array. So we're gonna have from length is gonna be equal to t, because it's gonna be the full length of, oh, I didn't parse these, did I? Map. Parsent t10. I need to do this. Okay. Now it should be good. And then go ahead and just fill with 0. Actually, okay. Let's do a, it's not a reduce, it's gonna be another map. And for this one, oh, that's missing. So this is going to be the time since started. So what was the math? It was, for each whole second you spend at the beginning of the race holding down the button, the boost increases by 1 millimeter per second. Gotcha. Okay. So it's just going to be, it's actually pretty simple. I don't actually need to do, I can do this. It's going to be, I don't actually need O, I just need I. It's going to be I times T minus I, right? So these are our options. Which actually is just that. So here is all of our options. Yeah, it's an array of array, right. So what we need to do is we need to do options filter, not filter, this is reduce, this is gonna be product, and then time, or option, and we're gonna give it options. Oh no, we're gonna give it 0 start, or 1 to start. yeah, 1 start, because it's, yeah. Okay. Return product for now. So what we need to do is we need valid is gonna be options filter. This also needs an index, I think, right? That's index. Yes, okay. Because we're gonna need dist. This is the record distance. It's gonna be distances index. And so we're gonna have to filter where the option, it's a number, right? Yeah, where the option is greater than the record distance. This is all our valid options, and now we're gonna have to reduce this to, again, product and O. It's gonna be P times O, I think, right? It's just product. You just multiply all of them together, and then you multiply all those together. Right? Part 1. Alright, we're gonna just throw it through, and we're gonna hope that I did it right the first time through. Haha, I did do it right the first time through. Try it again. Okay, I'm not saying that's wrong, but it doesn't, it might just be in very big scientific notation. What am I expecting from this? I'm expecting 280. Oh. Okay. What if I log options real quick? Where am I going wrong? Okay, so the first one is going to be 0, 6, 10, 12, 0, 6, 10, 12, 10. Yeah, okay. And then I'm actually going to go ahead and console log valid. So that seems to be right. And so we're going to get valid, which is not right. Oh, because that's distances. Right. It's not O. Because at the distances, it's going to be multiplying. Oh, wait. I messed this up. No. This is sum. Actually, no. It's just length. One, that way it gets through. 32. Okay, we're making progress. 4800. Okay. It should be 489. Wow, we're missing a 9. Can I get options again? Why am I missing? Wait, why is a third? Something, wait, why is, well, let's hold on. One of these is, I don't know why I'm getting a nothing here. Not a number. Why am I getting not? Because it's 3. Okay. We're gonna just do some cleaning. That should fix it. So I'm just gonna have to do some manual trimming of my input. That's fine. 288. 288. Okay. Alright, so we're going with this. I need to do some manual cleaning of the input here. Whatever. Alright, what am I getting now? This number. Beautiful! Alright. As the race about to start, you realize the piece of paper with the race times and record distances you got earlier actually just has a very bad kerning. There's usually only one race. Ignore the spaces between the numbers on each line. Oh. Okay. Alright, I think I can do it without having to do new input. I could do new input, but we're not going to. Thanks a bit. So what's gonna happen is I'm gonna steal this. It's gonna be time and it's gonna be distance. line 0, substring, and no trim because it's going to be just a replace all of spaces to no space. Makes it easy. And no map because we throw this right into a parse int. Go to that, go to that. Okay, so what that means is we don't need a map. I just realized I'm doing map and map here. That's whatever. I ignore the double map. So length of 1. How do I do this? I am blanking. Okay, so it's just gonna be options is gonna be equal to basically this. Okay. Basically just taking this. Why? Wait. That goes to there. Okay, and it's gonna be time, and then straight to a filter, right? With a length. Right? I'm not crazy, right? That's all it is. Is it just really slow? It's just really slow. But not too slow. But not too slow. Alright. Today was much better than past days. I might try and clean this up to make it a little bit faster. So give me a second, and if I can, we'll come back either way, and I'll go over how I solve this. Okay, so I didn't really clean it up a bit, or I did some polishing just to condense it down a bit. Nothing too much. I am realizing now that there is I'm not sure a simpler solution, but there's another way to go about this. But because this is optimization, and the optimization is the fastest time will always be around the middle of the times. It's like a mirror image. Like if I actually output, I can't now that I've done this. I can do this here. We'll see. This will be in a second. It might be a really long list. You can see, but because it's the optimization, actually you can see it in the problem too. You get this case where, 0 seconds at 0, 1 is 6, 10, 12, 12, 10, 6, 0. It goes to a point and then it goes back in just a mirror image of that. So because of that, you could do it to where you just get the opening bit, you go up until you get to where you first break the record, and then you find then where your max is. Then when you start going down, you can just take that those numbers there, multiply by 2, and you get your full answer. That way you're only going through half the list, and that way you're not actually having to keep the whole list in memory. You can just kind of count up as you go. Another way to do it that is much more efficient than this, but the way I did it works, and it's a very valid solution if you don't think of the more efficient way right away. So at any rate, for today, it's right that I can't do that because it's a length. Anyways, for today we're giving this inputs. Parsing is not hard. I just chop off time and distance, and then I actually cleaned up myself to only be space between the numbers. So that way then I can just split these into a list of times and distances. Part 1, we go through and we basically map, we create a list of options for how far the boat would go if you're to hold the button down for the index length of time. So index 0 being 0 milliseconds, index 1 being 1 millisecond. If you hold the button down for that amount of time, how far would the boat go? That is what this bit is. And then after that, this reduce is just here to first filter out all of the distances that are less than the record distance. This math max here is just so that we always get 1, we don't get a 0, because that'll mess up the product here. But then once we get all of the options that are greater than the record distance, we count up how many they are with length, again to 1. That way we can multiply by product, and that returns the reduce, and that is our part 1 of just all the total options for each game or each race multiplied together. Part 2 is actually simpler in the fact that because it's only one race, we can just smash all those numbers down to 1 time and 1 distance, and then just do this internal bit here. Again, we create our array, map it to the time, and then we just do the exact same thing of filtering and the distance. We don't have to worry about this reduce. And that's it. Pretty straightforward, pretty simple. Again, there is a much more efficient method out there than I did. This is just what came to my head first, and it works, so I can't complain. But anyways, that is day 6. Hope you guys enjoyed. I'll see you guys all tomorrow for day 7. Peace out.